You guys all know what a singleton set is. I think
Yes, sir. Which set have only one?
yes, Sital has done it right. Debraj I think has done it right. Well, singleton set. I had given you a set like this, and I asked you is it a singleton set or not. And
Yes, sir. It is a single term set.
yes, it is a singleton set, isn't it? Because it has only one element in it. Even though it looks like there are two elements, actually there is one element. Because in a set, no element is counted more than once. No element is counted more than once. So no matter how many times you write 1 here, you will count it only once. Okay, so it has only one element. You got it? So it is, of course, it is a singleton set, isn't it? Hello. 1 second, guys.
Yes, sir.
Yes, sir.
Yes, sir.
1 second, guys. Interruptions. Huh? Okay, no more interruptions. Let's continue. Huh. So singleton set, you got it. So of course this is singleton set, isn't it? Hello. Okay.
Yes, sir. It is
Yes,
a
sir.
single term set.
Okay. And a few other mistakes most of you have made. Should check it out. Okay. Okay. Today let's start with our permutation combination chapter. It's a new chapter and entirely new for you. Okay. But very easy. Okay. Where is it? It's after this. Okay. Yes, here it is. Permutations and combinations. Okay, it is a portion of algebra. Okay, it is a chapter from algebra. Okay, we have already covered complex number, right? We have already covered complex number from algebra. We have already covered sequence series from algebra. Okay, so now we're going to start with permutations and combination. Okay, clear? Okay. But before we start with permutations and combination, first of all we need to know something about the factorial. What is factorial? Okay, factorial. Let's talk about factorial. Factorial of n, where n is a natural number. How to find factorial of a natural number, or what is factorial of a natural number? Okay. So remember, factorial of a natural number is denoted as, factorial of n is denoted as n, and there is an exclamation mark right after it. Okay, it is called n factorial. It is read as what? N factorial. N factorial, and n is what? N is a natural number. Remember, n is a natural number. N factorial is equal to n into the previous natural number n minus 1 into its previous natural number n minus 2 up to 1. You get it? Up to 1. You get it? Suppose for example, I ask you what is the factorial of 5 or 5 factorial. 5 factorial is equal to 5 into its previous natural number 4 into its previous natural 3 into its previous natural number 2 into its previous natural number 1 up to 1. You get it? So that is 5 factorial. And what is it? 5s are for 20, 20s are 3. Hello? 60, 60s are 2, 120.
Yes, sir.
Sir, 60.
So 5 factorial is what? 120. Similarly, if I ask you what is 3 factorial, 3 factorial will be what? 3 into 2 into 1. Okay, 3 into its previous natural number into its previous natural number.
Sir, 6.
6. What is 2 factorial?
Sir, 2.
2 into 1.
Sir, 2.
And what is 1 factorial? 1 factorial is equal to 1.
1.
Okay.
1.
And yes. And without any explanation, you have to memorize this. Without any explanation, you have to memorize this for the time being. That a 0 factorial is equal to 1. You have to memorize this without any explanation for the time being. Okay? 0 factorial is
सर
equal
ये
to
सर
1. हाँ,
सर
yes.
ये सिंबल सर एक्सप्रेशन में मार्क का सिंबल सर फैक्टोरियल का सिंबल है.
Yes, you read it as factorial. Okay. So this is n factorial. N factorial is equal to n times its previous natural number n minus 1 times its previous natural number n minus 2 up to what? Up to 1. Okay, you get it? Hello, get it? So this is how you
Yes,
get
sir.
the
Yes,
factorial
sir.
of natural numbers. Also, you can do it like this. You can do it like this. N factorial is equal to. So here we did what? Here we went from n backwards up to 1. Even we can go from 1 forward up to n like this. n factorial is equal to 1 into 2 into 3 up to the natural number n. Okay, got it? So for
Yes, sir.
example, I
Yes,
ask
sir.
you what is 5 factorial. You can write it 1 into 2 into 3 into 4 into 5. Got it? What is it?
So 120.
120. Isn't it? Hello. Got it?
Yes, sir.
Okay.
Yes, sir.
Similarly, suppose I ask you 3 factorial will be equal to what? 1 into 2 into 3 is equal to 6.
So 6.
2 factorial is equal to what? 1 into 2 is equal to. So you can go from, if I ask you to find the value of n factorial, you can go from n into its previous natural number into its previous natural number up to 1 like this, or you can also go from 1 to n because they are the same, isn't it? Because multiplication is commutative. 1 into 2 into 3 to dot dot up to n is the same as n into its previous natural number up to 1, isn't it? Get it? This is how find factorial of a number. Okay, and 0 factorial is equal to 1. Without any explanation, you have to memorize it. Can you do it? Hello, did you understand everything?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
and keep in mind one thing. Note that factorial of negative numbers and fractions is not defined. Suppose somebody asks you what is the factorial of minus 5. Minus 5 factorial is not defined. Okay, factorial of minus 5 is not defined. Factorial of 1 by 2 is not defined. Okay, factorial of any negative real number or factorial of any fraction is not defined. Like 1 by 2, its factorial, it's not defined. It's not defined. You get it? Okay, so you can find
Yes, sir.
you can find a factorial of all the whole numbers, I can say. Factorial of 0 is equal to 1. Like I said, without any explanation, you have to memorize it. Factorial of 0 is equal to 1. After that, you can find factorial of all natural numbers. Okay, but factorial of negative numbers, factorial of fractions is not defined. Can you understand it? Okay, should we move on from this?
Yes, sir.
Okay,
Yes, sir.
so take the screenshot. Done? Okay.
Yes, sir. Done.
Okay. हाँ, yes.
सर अगर किसी बड़े नंबर का फैक्टोरियल निकालना हो तो उसके लिए कुछ फॉर्मूला है?
No, you have to multiply. Okay, or you can use a calculator. Okay, so now there is one important formula you have to remember, that n factorial is equal to n into its previous natural number n minus 1 factorial. Let's talk about it. For example, 5 factorial is equal to 5 into its previous natural number. What is the previous natural number? 5.
4.
So 4.
So 5 factorial is the same as 5 into 4 factorial. Now you see, isn't it logical? Because you see 5 factorial is what?
यस सर. सर लॉजिकल है.
Yes,
मतलब हम डायरेक्टली मल्टीप्लाई कर रहे हैं 4 के पहले वाले नंबर्स को.
yes. 5 into 4 into 3 into 2 into 1. Okay, 4 into 3 into 2 into 1 is what? It's 4 factorial, isn't it? So it is 5 into 4 factorial. You get it? Clear? Okay?
Yes,
Yes, sir.
Okay. So you see n factorial is equal to n into its previous natural number n minus 1 into its previous natural number n minus 2 up to 1. All the natural numbers up to 1. Okay. So I can write it as n into, well, from here to here, isn't it n minus 1 factorial? N minus 1 natural number is factorial.
Yes,
N minus
sir.
1. Okay. So you have to memorize this. Okay. So n factorial is equal to n into n minus 1 factorial. You have to memorize this formula. Okay. So you see here, n factorial is equal to n into n minus 1 factorial. Okay. Now let's do these two questions. Question is to convert the following products into factorials. Here bit number 1, you have been given a product 6 into 7 into 8 into 9 into 10, and we want to convert it into factorials. Okay, first of all take the screenshot of this. Okay, yes. Take the screenshot. Done? Okay.
Yes, sir. Done.
Oh. Now, the question is convert the following products into factorials. Convert into factorials. Well, the first question is 6 into 7 into 8 into 9 into 10. Bit 1. 6 into 7 into 8 into 9 into 10. And I want to convert it into factorials. Okay. How do I convert it into factorials? Now you see, we have the natural numbers from 6 to 10 here, right? 6 into 7 into 8 into 9 into 10. Now let's multiply this thing with 1 into 2 into 3 into 4 into 5. So that we will get the complete natural number from 1 to 10. First of all, you get it? But you see, since you are multiplying something here, you have to also divide that. Otherwise, the value will change, right? Do you get it? If you are
Yes, sir.
multiplying
Yes, sir.
something, if you are multiplying something with this, then you also have to divide that, so that the value remains the same. You see, if you cancel 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, you still get what? 6 into 7 into 8 into 9 into 10. So you multiply 1 of 1, 2, 1 into 2 into 3 into 4 into 6, 5 on the numerator, and you multiply 1 into 2 into 3 into 4 into 5 on the denominator. From 1 to 10, multiplication, natural numbers is what? 10 factorial, isn't it?
Yes, sir.
From 1 to 5, natural number multiplication is what? 5 factorial, isn't it? You get it? So
Yes,
done.
sir.
So done. You converted this product into factorials. Get it or not? Hello. Hello. Get it?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now let's talk about the next question. In the next question it says 2 into, see, this is multiplication product. 2 into 4 into 6 into 8 into 10. 2 into 4 into 6 into 8 into 10. Well, you see, 2 is what? Can I split 2 as 2 into 1? 2 is same as 2 into 1. 4 is the same as 2 into 2. 6 is the same as 2 into 3. 4 is the same as 2 into 4. 8 is the same as 2 into 5. Isn't it? Hello, get it? Now these 2 into 2 into 2 into 2 into 2. How many 2's are there? You see 1, 2, 3, 4, 5. 2 to the power 5. Then 1, 2, 3, 4, 5. Do you see here? 2 to the power 5
Yes, sir.
into. What is this? Isn't it 5 factorial? Got it? Hello, got
Yes,
it?
sir.
Yes, sir.
So we converted it to factorial. Okay, take the screenshot. These are 2 marks questions. Can everybody do these questions if they are asked in exam?
Yes, sir.
Okay.
Yes, sir.
Okay. Now, let's move on to the next question. Question is find the LCM of 4 factorial, 5 factorial and 6 factorial. Okay, I will give you the direct answer. It says LCM of 4 factorial, 5 factorial, 6 factorial. Well, I will give you a direct answer. It is a 1 mark question. Okay, the direct answer is the bigger one. Which one is the biggest one? Which one is the biggest here? 6 factorial. Do you get it? So the
Yes,
LCM is
6
6 factorial. LCM is what? 6 factorial. Hello, get it? Now you will ask
Yes,
me
sir.
how.
Yes, sir.
Now you will ask me how. Okay. So let me just remind you something here. Suppose I ask you what is the LCM of 6, 12, 24. You tell me what is the LCM of 6, 12, 24?
Sir, 24.
It's 24, right? It's 24. Why?
Yes, sir.
Because 24 is divisible by 6 and 12 and of course itself, right? 24 is the multiple of 6, is also multiple of 12 and of course is the multiple of itself, isn't it? Okay. Suppose I ask you what is the LCM of 2, 4, 12. What is the LCM here? 12, right?
Sir,
This
12.
12 is a
Yes,
multiple
sir.
of 2, 12 is a multiple of 4, 12 is a multiple of itself also. You know all this from 4th class. You see that 6 factorial is divisible by 4 factorial. Now you will ask me how? How is 6 factorial divisible by 4 factorial? Well, you see, 6 factorial is what? 6 into 5 into 4 into 3 into 2 into 1. Or can I write 4 factorial? 6 factorial
Yes,
is
sir.
equal to 6 into 5 into 4 factorial. So do you see here clearly that 6 factorial is a multiple of 4 factorial? Clear?
Yes, sir.
Similarly, 6 factorial will also be a multiple of 5 factorial, because I can write 6 factorial as 6 into 5 factorial, isn't it? So 6 factorial is a multiple of 4 factorial, 6 factorial is a multiple of 5 factorial, and of course 6 factorial is a multiple of itself. So what is the LCM of these three? 6 factorial. You get
That's
it?
6 factorial.
Suppose I ask you what is the LCM of 5 factorial, 20 factorial, 100 factorial. The answer is the biggest one. Okay, which one is the biggest here? 100 factorial. You get it?
Yes, sir.
100 factorial. Everybody get it?
Yes, sir.
Yes, sir.
Okay. Take the screenshot. Done?
Yes,
n
sir.
factorial plus 1. अच्छा ठीक. Okay. So take the screenshot. Done? Okay. Now let's move on to the next portion. Now I will briefly tell you about fundamental principle of counting today. Okay, fundamental principle of counting. Let's first write the definition of fundamental principle of counting. Fundamental principle of counting. Now before I tell you the definition of fundamental principle of counting, let's first try to understand it. Okay, fundamental principle of counting is what? Okay, it is basically counting. Okay, and it is used for bigger countings, because for smaller countings we can easily do it in our head, but for bigger countings we use fundamental principle of counting. Let's just take an example. Suppose you have 2 shirts and 3 ties. You get it? Suppose you have 2 shirts and 3 ties. Now question is, in how many ways can you dress yourself in a shirt and a tie? In a shirt and a tie. Here you have 2 shirts, 3 ties. Now the question is, if you want to wear a shirt and a tie, in how many ways can you do it? Okay, so let's just do it in layman, in the way a layman does it. Right? For example, you see, we have 2 shirts here, right? So let's say the 2 shirts are S1, S2, and we have 3 ties here. Let's say the ties are T1, T2, T3. You get it? Now I want to wear 1 shirt and 1 tie. Okay, get it? I want to wear 1 shirt and 1 tie. Now see, if I want first for example, I want to wear shirt, then I want to wear tie. Okay, so if I want to wear a shirt, I can choose from S1 or S2, right? I can wear shirt S1 or shirt S2, right? Clear?
Yes, sir.
Now
Yes, sir.
if I choose shirt S1, then with it I can choose tie 1, or I can choose tie 2, or I can choose tie 3. Similarly, if I choose shirt S2, with it I can choose tie 1, I can choose tie 2, or I can choose tie 3 to wear, right? So now the question is, in how many different ways can I wear a shirt and a tie? Well, look here. This is one way, shirt 1, tie 1. This is another way, shirt 1, tie 2. That is, you can wear shirt 1 and tie 1, or you can wear shirt 1, tie 2, or you can wear shirt 1, tie 3, or you can wear shirt 2 with tie 1, or you can wear short 2 with tie 2, or you can wear short 2 with tie 3. So how many different ways can you
Sir,
dress?
6 different ways.
6 different ways, right? So there are 6 different ways in which you can choose a short and a tie. You get it? There are 6 different ways.
Sir,
in
3
which-
factorial answer है sir इसका.
Yes. Coincidentally, the answer is 3 factorial, but that's not the point here. Coincidentally, that is coincidence. But do you get it? Hello? 6 ways you can wear the tie. Okay.
Yes, sir.
Let's just take another
Yes, sir.
example. Let's take another example. Suppose there are 3 towns. Town A, town B, town C. Now there are suppose 2 roads to go from town A to town B. Okay? And suppose there are 3 roads, or let's say 4 roads, because we have already taken 2, 3. Let's suppose there are 4 roads to go from B to C. Clear? And let's just name them. R1, R2, R3, R4, R5, R6. Now, suppose you want to go from town A to town C via town B. Suppose you want to go from A to C via B. Now, the question is, in how many ways can you do it? Well, let's check it out. See, you have to go from A to C via B. You cannot there is no way you can directly go from A to C. The question is, you have to go from A to B first, then from B to C. Your target is to go from A to C, but you have to go via B. You get my point so far? Now, in how many ways can you do it?
Yes, sir.
Now, think about it.
6.
No. Think about it. To go from A to B first, you have to first go from A to B. Now, to go from A to B, you can choose road 1 or road 2, right? Either of the 2 roads you can take. Now, suppose you chose road 1. Suppose you chose road 1 to go from A to B. Suppose you chose this road. Then you have to now go from B to C. So, to go from
Sir,
B
there are
to
8
C,
ways.
Yes. To go from B to C, you can choose road 3, road 4, or road 5, or road 6, isn't it? Similarly, suppose you choose road 2 to go from A to B. Now, to go from B to C, okay, you have 4 different choices, right? You can choose road 3, or road 4, or road 5, or road 6. Do you see here? Now, in total, how many different ways can we go from A to C? Well, we can go from A to B using road 1, then from B to C using road 3. So, this is one way. Or you can go from A to B using road 1, then from B to C using road 4. Another way. Like this, how many ways are there?
Sir, 8 ways.
8 ways. Do you see here that there are 8 different ways that you can choose to 8 different ways to choose from to go from A to C via B. Clear? Okay. Okay. Now, in these 2 examples, let's just see a pattern, and let's just name this concept as fundamental principle of multiplication. Let's call it fundamental principle of multiplication. Then we'll talk about fundamental principle of addition. Fundamental principle of multiplication. So let's talk about the first example. See, in the first example, our task was to wear a shirt and a tie. What was our task? To wear a shirt and a tie, right? It was our task. What? Wear a shirt and a tie, isn't it?
Yes, sir.
Now you see, the task to wear a shirt and a tie is being completed in 2 steps. In step 1, you have to choose a shirt. Then after you choose a shirt, then you have to choose a tie. Isn't it? In 2 different steps, this entire task is being completed, right? If you have to wear a shirt and a tie, you have to do 2 things. You have to choose a shirt, then you have to choose a tie. After choosing a shirt, you have to choose a tie. Like, for example, you chose shirt 1, and after that you have to choose any one tie, right? Like T1. Or First you choose a sort S1, then you choose tie T2. First you choose sort S1, then you choose tie T3. You get it like this? So you see here the
Yes, sir.
task of wearing a short and a tie is being carried out in two different steps. And these two steps are called two events. They are called what? Two events. Okay? Two event. Event number 1. To choose a short. And what is event number 2? To choose a what? Tie. Okay.
A tie.
So the entire task of wearing a short and a tie is being carried out through two events. First event 1 happens, that is first you choose a short. After event 1 is completed, then event 2 happens, that is you choose a tie. Then your entire task is complete. Now you tell me, event 1, to choose a short, how many ways can you do it, or how many ways can event 1 happen? Well, event 1 can
Sir,
happen
two
in
ways.
two different ways, right? Event 1 can happen in two different ways, isn't it? Event 1 can happen in two different ways, right?
Yes, sir.
Because you have two sorts to choose from. Now, after event 1 is completed, event 1 is completed means you have already chosen some sort, right? Either you have chosen sort S1 or S2. One of these you have chosen. After event 1 has completed, after you have chosen a sort, now event 2 can be completed in how many ways? For example, you have chosen some sort. For example, you have chosen this sort. Now, event 2 is what? To choose a tie. Now, after event 1 has happened, after you have chosen a sort, then event 2, that is to choose a tie, it can happen in three different ways. Isn't it? Do you see here?
Yes,
Hello,
sir.
you see here?
Yes, sir.
So event 1 can happen in two different ways. Following which means what? After event 1 has already occurred, event 2 can happen in how many ways? Three
Sir,
different
three
ways.
different ways.
Now you see the entire task of wearing a short and a tie is happening in two different events. The first event can happen in two different ways. After the first event has already occurred, the second event can happen in three different ways. So the entire task of wearing a short and a tie can happen in 2 into 3 is equal to 6 different ways. You get it? Therefore,
Yes,
the
sir.
total different ways to wear a short and a tie is equal to 2 into 3 is equal to 6. Now let's talk about the next example.
सर
Yes.
सर ये एंट्रीज हमें लिखनी पड़ेंगी, ये सारी एंट्रीज.
No. These are for explanation only. These are for explanation. Now let's talk about this example. Here also let's talk about what is our task at hand here. Here our task is what? Our task is to go from A
We have to reach A to C via B.
Yes. That's our task, to go from A to C via B. Now the question is, in how many steps are we doing this task? 2 steps,
Two
right?
steps.
First we are go from A to B. Then after we have reached B, then we go from B to C. Then our entire task is complete. So here our entire task is being carried out in two different events. Let's call them two events. Event 1 is to go from A to B. Then event 2 is to go from B to C. Get my point so far? Now after event 1 and event 3 or 2 both have happened, the entire task is complete. Right? Like here. Here, event 1 was choosing a short, event 2 was choosing a tie. After event 1 first happens, after which event 2 happens, then the entire task is complete. Both events have to happen one after another. Here also there are two events. First event 1 will happen, that you will go from A to B. After it has occurred, event 2 will happen, that you will go from B to C. Event 1 will happen, then following which event 2 will happen. After the 2 event has happened, then the entire task is complete. Isn't it? Do you see here?
Yes, sir.
Okay. Now you see the event 1, which is to go from A to B, can happen in how many ways here?
Sir, two different ways.
Yes. Now, imagine event 1 has already occurred. Event 1 has already occurred. Remember, here in these examples, both events have to happen one after another for the entire task to be completed. Both events have to happen one after another. Now, event 1 has already occurred. That means you have chosen some road from R1 or R2, you have chosen one of them, and now you are at place B. Now you are at town B. Now you want to go from B to C. Event 1 has already happened. Now event 2 is about to happen. Now you tell me, in how many different ways event 2 can happen now?
So, four different ways.
4 different ways, right?
Yes, sir.
Everybody got it? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Event 2 can happen in 4 different
Different ways.
ways. Now you tell me, in how many different ways can the entire task of going from A to C via B can happen? How many different ways? We have already seen that in 8
Sir,
different
eight
ways,
different
right?
ways.
Sir, in 8 different ways.
And here also you see that the entire task, the task of going from A to C via B can occur in 2 into 4 is equal to 8 different ways. You get it? Hello?
Yes, sir.
Yes, sir.
Okay. So let's just take some questions from your book itself. First question. This example. It says in a class there are 10 boys and 8 girls. In a class, so you first take the screenshot. Take it.
Done, sir.
Done.
Done, sir.
Okay.
Done, sir.
So let's just take this example from your book. Then I will give you the formal definition of fundamental principle of multiplication. It says that there are 10 boys and 8 girls in your class. 10 boys and 8 girls in your class. The teacher wants to select a boy and a girl. The teacher wants to select a boy and a girl to represent the class in a function. A function is going to happen and the teacher has to select a boy and a girl. Okay, he has to select a boy and a girl from the class. Now the question is, in how many different ways can the teacher make this selection? Okay. So before we go on to do this question, first let's just try to make ourselves comfortable with this question. So in order to do that, let's just take a small example. It says 10 boys and 8 girls. Let's just take a small example. Suppose there are 3 boys and 2 girls in a class. And I want to, or the teacher wants to select a boy and a girl, okay, to represent in a school function, represent the class in a school function. Now the question is, in how many different ways can the teacher do that? Well, let's try to understand the task at hand here. What is the task here? To select a boy and to select a girl, right? You have to select a boy and a girl, right? Get it? Now suppose there are 3 boys, B1, B2, B3, and there are 2 girls, G1, G2. Now,
Sir, G1 can go with B1, B2 and B3, and same as G2 can go with B1, B2 and B3.
Yes, very good. So 6 different ways, right? Or you can also go from boy to girl or girl to boy. It's up to you. Okay, first you can choose a boy, then a girl, or first you can choose a girl, then a boy. It's okay, right? There is no issue here. Whichever you
Yes,
want. Okay. So for example, the teacher has to select. Okay, the teacher has to select a boy and a girl. Okay, the task is to select a boy and a girl, and this will happen in two different events. Event number 1, he will select a boy. Then event number 2, he will select a girl. Now suppose the teacher decides to select a boy first. Now he can select a boy B1 or boy B2 or boy B3, right? It's up to the teacher. Now if he selects boy B1, then with him he can select girl 1 or girl 2. Similarly, if he selects boy 2, with him he can select girl 1 or girl 2. If he selects boy 3, he can select girl 1 or girl 2 with him. Right? You get it? So now
Yes,
the
sir.
question is, in how many
Yes, sir.
different ways can the teacher do it? B1 G1, B1 G2, that is boy 1 girl 1, boy 1 girl 2. Boy 2 girl 1, boy 2 girl 2, boy 3
Sir,
girl
6
1.
different ways.
6 different ways, isn't it? In 6 different ways the teacher can do the task. Now let's just try to understand this question. Let's just try to understand this example the way you understood the previous examples. Here also two events are happening. The first event is choosing a boy. Now after event 1 happens, event 2 happens. Both events have to happen. Here both events have to happen. I am stressing this. There is a reason why I am stressing this. There is a reason why I am stressing that both events have to happen, because then we will talk about fundamental principle of addition. So keep in mind here, both events have to happen. Boy, then a girl. Now event 1, to choose a boy, it can happen in 3 different ways, right? After that, right, after a boy has already been selected, suppose event 1 has already occurred, now a boy is selected. Now the teacher goes on to select a girl. Well, he has 2 different ways to select a girl, right?
Yes, sir.
So event 1
Yes,
can
sir.
happen in 3 ways, following which event 2 can happen in 2 different ways. Now the entire task can happen in how many different ways? 3 into 2 is equal to 6
Yes,
different.
6 different ways.
So now we can do this question very easily. Here we
Yes, sir.
have 10 boys and 8 girls in our class. We have to select a boy and a girl. Suppose the teacher wants to select a boy first, then a girl. It's okay, no issues. Same thing, right? If you want to select a boy and a girl, same thing, right? Ram, Sita, Sita, Ram. Are they 2 different things? If you are selecting Ram, Sita for the school function, Ram, Sita, Sita, Ram, are they 2 different things? No, it's up to you. You can select a boy, then a girl, or a girl, then a boy. No problem. Okay. So here the entire task of choosing a boy and a girl will happen in 2 different events. The first event, which is to choose a boy, it can happen in how many ways?
8 different ways.
Sir, 10 different ways.
And after a boy has been chosen, now the second event, that is to choose a girl, will happen. It can happen in how many ways? 8 ways.
8
Eight
different
ways.
ways.
So total 80 different ways the teacher can choose a girl and boy and a girl. Also you can go the other way around. First girl, then boy, it's okay. 8 into 10, 80. Okay. No issues there. Take the screenshot. Okay, done. Okay, take it.
Done, sir.
Done. Okay.
Done, sir.
Okay. Huh. Now let's take up another question. Let's take up another question. And before we take up another question, first let's just try to let me just give you the definition. Okay. The definition of fundamental principle of multiplication in the book, the definition is a bit a bit wrong. Okay, bit wrong written somewhere. So let's just write the correct definition. Fundamental principle of multiplication. Okay, fundamental principle of multiplication. Now the definition is, if a task is carried out in two different ways. In two different events. In two events. If a task is carried out in two events, event 1 can happen. If event 1 can happen in m different ways, following which, but guys, following which means what? Who can tell me? Following which means what? Means after event 1 has already occurred. Okay, after event 1 has already occurred. Following which event 2, you get it? Event 2 can happen in n different ways. In n different ways. Then the total number of ways the task can be completed, then the total number of different ways the task can be completed is equal to m into n. M into n different way. In m into n different ways the entire task can be completed. That's why we call it fundamental principle of multiplication. Get it? Now note, FPM means fundamental principle of multiplication, can be extended to any number of events. Any number of events. So don't think that fundamental principle of counting, this concept will be applied only when there are two events. No, as many number of events as there can be, no problem. Okay, so let's take an example. Suppose you have two shirts, 3 ties, and let's say 4 pairs of shoes. You get it? Hello?
Yes, sir.
Now the question
Yes, sir.
is, in how many ways can you dress yourself in a shirt and a tie and shoes? In how many ways?
Sir, 20 ways.
How 20? In how many ways can we dress in a shirt?
Sir, 24. 24.
Sir, 24 ways.
Yes. A tie and a pair of shoes. So of course here the entire task is what? To wear a shirt, a tie and a pair of shoes. Our task is to wear a shirt, a tie and a pair of shoes. This is, it says and. You have to wear all three compulsorily. Now first you have to wear a shirt. Now we can do it in two different ways, right? There are two shirts. Now after we have chosen a shirt, now when we go to choose a tie, we can do it in three different ways, right? Because we have 3 ties. Now a shirt and a tie have already been chosen. Now we move on to choose a pair of shoes. Well, we have 4 pairs of shoes, so we can do it in 4 different ways, right? We can choose from 4 different pairs of shoes, right? So here
Yes, sir.
in 3 different events, the entire task is being carried out. Event 1 to wear a shirt, event 2 to wear a tie, event 3 to wear a pair of shoes. Event 1 can happen in 2 different ways, following which event 2 can happen in 3 different ways, following which event 3 can happen in 4 different ways. So the entire task can be carried out in how many different ways? 24 different ways,
24.
right?
24.
Okay. So take the screenshot, then we'll talk about fundamental principle of addition, and in the next class, tomorrow also 4:30 there will be a class. Okay, 4:30. Clear? 4:30 clear.
Okay, sir.
Take the screenshot. Done?
Done, sir.
Oh. So now let's talk about
Sir, tomorrow 4:30.
Yes. Why? Is there any problem?
No sir, मैंने थोड़ा सुना नहीं था ढंग से.
Okay. So let's talk about fundamental principle of addition. See, fundamental principle of addition, it is a bit different from fundamental principle of multiplication. How it is different? Let's just take an example. Suppose you have a city here, city A. Suppose you have a town here, okay? Suppose you have town A here. Suppose you have town B here. Suppose you have town C here. You get it? Now suppose there are two roads to go from A to B. Let's call them R1, R2. And suppose there are three roads to go from A to C. Let's call them R1, sorry, R3, R4, R5. Now here our task is to leave town A. Our task is to leave town A. It is our task to leave town A. Now you see, if we want to leave town A,
There are 5 different ways.
yes. If you want to leave town A, what can you do? You can either go to town B or you can go to town C, right? If you want to leave town A, so either you will go to town B or you will go to town C. Isn't it? Isn't it?
Yes, sir.
Yes, sir.
You see, here two events are also involved here. Here also two events are involved. Two events. Event 1 to go from A to B is one event. Event 2 to go from A to C is the second event. But the thing is, unlike the previous examples, here both events do not have to happen together. One of them has to happen. Either you go from A to B or you go from A to C. Remember in the previous examples, you have to wear a shirt and a tie and a pair of shoes. You have to go from A to B and then go from B to C compulsorily. Both events have to happen one after another. But here, both events do not compulsorily have to happen. Either of them will happen. You get it? Either you will go from A to B or you will go from A to C. Hello, get it?
Yes,
Okay.
sir.
Now,
Yes, sir.
in this case, so the task is to leave town A. Actually, we can translate it as the task is to go from town A to town B or to town C. The word or is very important. Here. Here I am using the word or. There I was using the word and. In case of fundamental principle multiplication, I was using the word and, but here I am using the word or. So the task that is to go from that is to leave town A can happen in how many different ways? Now 2 plus 3 is equal to 5 different ways. Now you see for yourself, isn't it true? See, you have to leave town A, isn't it? So either you can take road 1 or road 2 or road 3 or road 4 or road 5. Any of these 5 roads you can choose, then you will leave the town A, right? You can leave town A by any of these 5 roads, isn't it? Hello. So there are 5 different ways. Clear? Hello.
Yes,
Yes,
sir.
sir.
Okay. Now let's take another example. Example is, we have 2 shirts and 3 ties. Now the question is, in how many ways can we dress in a shirt or a tie? So now I changed and into or. There I was using in how many ways can we dress in a shirt and a tie, but here I am saying in how many ways can we dress ourselves in a shirt or a tie. That means here it is not mandatory that you have to choose a shirt and a tie both, right? Here you have to either choose shirt or you choose a tie. You get it? Either you choose a shirt or you choose
Yes, sir.
you choose a tie, and the task will be complete. Here the task is to choose either a shirt or a tie, not
So
both.
5 different ways to do
5.
this task.
Yes, 5 different ways, isn't it? Clear? 5 different ways. Now how? So let's see. We have two sorts here, right? Say, let's say S1, S2 and three ties here, T1, T2, T3. Now I am saying that there are 5 different ways to do this task. Let's see how. Suppose you choose S1. Our task is complete, right? Because what is the task here? To dress in a shirt or a tie. Not both, right? Either a shirt or a tie. If you choose S1, task is complete. If we choose S2, task is complete. T1, T2, T3, right? So there are 5 different ways to do this, right? So the definition, hello, get it?
Yes, sir.
So the definition
Yes, sir.
of fundamental principle of addition. Let's talk about the definition of fundamental principle of addition here. A PA. Achha, the example that I was doing, n factorial plus 1, was I saying that n factorial is if divide n factorial by 2 we get remainder 1? I was saying that, or I was saying correctly? What was I saying? Because I was hello.
Sir, you are saying when
Yes,
we divide n factorial plus 1, it will give remainder 1.
Okay, because at that time I was a bit distracted because three women have three women came over to my house. So you understand, right? They were talking loudly over there, so I was a bit distracted, so I had to close the door. Okay, but I was saying correctly, right? But I was a bit distracted there. Hello.
Yes, sir.
Yes, sir.
Okay. Fundamental principle of addition. Let me give you the definition. Now, if a task can be completed either by event 1 or event 2, either by event 1 or event 2, not both. You see, let's say, and let's say event 1 can happen in m different ways, and event 2 can happen in n different ways. Sorry. Then the task is completed in, then the task can be completed in how many ways?
M plus in different ways.
M plus and different ways. So take the screenshot. So I hope fundamental principle addition and multiplication you completely understood, right? In fundamental principle
Yes, sir.
multiplication, both have to happen, both events have to happen, but here either of the two events have to happen, not necessarily. Okay, take the screenshot. Done?
Done, sir.
Okay, so you can also try some questions here. You see this question you see here, it says in a class there are 10 boys and 8 girls, just the previous question, but there is a bit difference here. The teacher wants to select either a boy or a girl to represent the class in a function. What was the question here? Now here the question was, the teacher wants to select a boy and a girl. Here the teacher has to select a boy and a girl compulsorily. But here the question is different. Here the teacher has to select either a boy or a girl.
So there are 18 different ways to select.
18, right? Not both, either, right? Either boy or girl, not both. You get it? Okay, so 18 different ways, right? Here there are two events. Event 1 can happen in 10 different ways, event 2 can happen in 8 different ways, and the task which is to select a boy or a girl can happen in how many ways? 8 plus 10 plus 8, 18 different ways. Can you do it or not? Hello?
Yes, sir.
Yes, sir.
Just take this example. In a monthly test, the teacher decides that there will be 3 questions, one from each exercises, exercise 7, 8, 9 of the textbook. So in your textbook there are 3 exercises, exercise 7, exercise 8, exercise 9. and the teacher decides to ask 3 questions, one from each exercise. Okay, one question from exercise 7, one question from exercise 8, one question from exercise 9. Okay, the teacher want to ask. If there are 12 questions in exercise 7, suppose there are 12 questions in exercise 7, 8 questions in exercise 2, okay, the see printing mistake. If there are 12 questions, 7, 8 in what? And 9 of the text book. If there are 12 questions, 7, printing mistake. If there are 12 questions, 7, 18 in exercise 8, 9 in exercise 9. Okay, so forget this sentence. It's written wrongly. Okay. So if there are 12 questions in exercise 7, 18 questions in exercise 8, and 9 questions in exercise 9. 12 in 7. Let me erase it. Exercise 7. How many questions are there? 12 questions, right? 12 number of questions.
Okay, sir.
Exercise 88, 18 number of
Sir, 18
questions.
questions.
Exercise 9,
Sir, 9
9
number of
questions.
questions.
Now the question is, how many different ways can the questions be selected, or how many different ways can the teacher do that? Well, what is the task here? What is the first? Let's try to understand the task. Can anybody tell me what the task here is? The task here is to choose 3 questions, one from each exercise, right? One from each exercise. One question from this exercise, and one question from this exercise, and one question from this. Okay, we have to choose 3 questions. So compulsorily here we have to choose a question from exercise 7, then from 7 exercise 8, then from exercise 9. So in 3 different events this task can be completed, right? And all 3 have to happen one after another, right? All 3 have to happen. All 3 have to happen. Okay, here it is not either or case. Here all 3 have to happen, right? First you have to choose from exercise 7, then from exercise 8, then from exercise 9. Now event 1, which is to select a question from exercise 7, it can be done in 12 different ways because there are 12 questions in it. Now after event 1 has already occurred, that I have already chosen a question from exercise 7, now I am going to choose a question from exercise 8. Event 2 is about to happen, which can happen in how many different ways? 18 different ways. After that, now my task is, the next event is to choose a question from exercise 9, and there are 9 questions in it. So in how many ways can I do it? 9 different ways. So the entire task, which is to select a question from each of these exercises, can occur in how many ways? 12 into 18 into 9. Whatever is the answer. You get it? Hello?
Yes, sir.
Yes, sir.
Okay. So this is the last question we'll do, and then I will leave you. Okay. This is the last question. The question is, so there are these digits. Okay. 0, 2, 3, 4, 5, 6. It says how many 3-digit numbers can be formed without using these digits. And what are the digits that we are forbidden to use? We can't use these digits. What are these digits? 0.
Sir, 0, 1, 2, 3,
No,
4,
G-
5,
G-
6.
No, not 1. 0, 2, 3, 4, 5, 6. We can't use these digits. Well, if we can't use these digits, then which digits shall we use? Which digits can we use? 1.
So 1, 7, 8, 9.
Sir, 8, 9.
Okay. So we have to use these digits first of all, because these digits you can't use. So we have to use this. Now what is our task here? To form a 3-digit number. Okay. Our task here is to form a 3-digit number. So that means we have available 1, 7, 8, 9. We have 4 digits available here, 1, 7, 8, 9. We have to form a 3-digit number, right? Now you see a 3-digit number has 1's place, 10's place, and 100's place, right? Now forming a 3-digit number, it is the same as putting a digit in 100 place, then putting a digit in 10's place, then putting a digit in 1's place. Now once you have put 3 digits in the 3 places, your task is complete. You have yourself a 3-digit number, right? That is our task, to form a 3-digit number. Now the question is, how many 3-digit numbers, such 3-digit number can be formed? Well, let's just understand it this way. In how many ways can we put 3 digits in these 3 places? That is the question here, right? Right? The number of ways we can put 3 digits in these 3 places, that many number of 3 digit number we shall obtain, right? I got it.
Yes, sir.
Okay.
Yes, sir.
Now the question is, in how many ways can we do it? Okay. So here you see the entire task, which is to fill these 3 places, 100 place, 10s place, 1s place. It will happen in 3 different events. Event 1 is to fill the 100 place. Event 2 is to fill the 10s place. Event 3 is to fill the 1s place. So suppose you want to fill the 1s place first. Now you see, in order to fill the 1s place, how many ways can I do it? Well, I can put here 1, I can put here 7, I can put here 8, or I can put here 9. In the 1s place, I can put either of 1, 7, 8, 9, right? One of them I can put, right? Bindas, right? So
Yes,
4
sir.
different ways. In 4 different ways, I can fill the 1s place. Right? Now suppose I have already filled the 1s place. That means event 1 has already happened. Event 1 has already happened. Event 1's place is already filled. Now we go on to fill the 10's place. Well, now the question is, in how many different ways can I fill the 10's place now?
So 4 different ways.
Four different ways.
Of course 4 different ways, right? Of course 4 different ways. Because has it said anywhere that the digit that I place here, that I cannot repeat here? Has it said anywhere repetition is not allowed? Has it said anywhere repetition is not allowed? That the digit
No,
that
sir.
you use here, you can't use it here? Has it said anywhere? No. It is simply asking us to form a 3-digit number, right? A 3-digit number. In a 3-digit number, a digit can be repeated. For example, 777. It is a 3-digit number. It has not given us any restriction. So of course, after placing a digit in the 1's place, I can choose choose from 4 different ways to fill the 10's place. Then after that, I can choose from 4 different ways to fill the 100's place. Now according to fundamental principle of multiplication, you see all the 3 events have to happen one after another here for the entire task to complete. The entire task can happen in how many different ways? 4 into 4 into 4. You get it?
64 different ways.
That means 64 different ways you can fill these 3 places with 3 digits. And every time you will get a 3-digit number. So how many 3-digit numbers do you get then? 64 3-digit numbers. You get it? You get it?
Yes, sir.
Okay.
Yes, sir.
Now this is one bit where I allowed repetition. Where I allowed repetition. Repetition is allowed. I allowed repetition of digits. Now the second bit, I am not going to allow repetition of digits. In the second bit, repetition not allowed. Well, repetition not allowed means you can't use the same digit in any 2 places or more, or 3 places. You can't. You have to use one digit only once. You get it? You have to use one digit only once. Suppose you have placed 7 here in the 1's place, then you can't put 7 here or here. You get it? That's it. Here there is a condition. The condition is repetition is not allowed. Or we can say it like this, that the 3-digit number that we want should have all 3 distinct digits. Isn't that same? Distinct digits means what? Different digits, right? If I want to phrase my question this way, I will say that the 3-digit number I want to form, it should have distinct digits. Distinct digits means what? Digits are not repeated. I get it. So now the question is, in how many different ways can we do it? Hello, get it or not? Why are you not responding?
Yes, sir.
Yes, sir.
1, 7, 8. So these are the digits available for us to use, because we can't use the other digits that you know. And here also the same thing, we have to fill the 1's place, then you have to fill the 10's place, then you have to fill the 100's place. Now the question is here, repetition is not allowed. Well, if we want to fill the 1's place first, then you see the 1's place can be filled in 4 different ways. I can choose 1, 7, 8, 9, whatever, right? 4 different ways. You get it?
Yes, sir.
Yes, sir.
Now think about it here. Here the task is to fill these three places with three digits. That means here the three events, all three have to happen one after another. All three events have to happen one after another. That means you have to fill the ones place, you have to fill the tens place, then you have to fill the hundreds place. So event 1, which is to fill the ones place, can happen in 4 different ways. Now it has already occurred. That means you have put some digit here. Now you tell me which one have you put here. It's up to you, whichever. Which one have you put here? 1, 7, 8, 9. Which one? Arey, choose one. Suppose you have put 8 here.
So then we have in the 10th place we have 3 different ways, and at the
Yes.
100th place we
Yes,
have 2 different ways only.
Yes. So here we have 3 different ways to fill this tens place. We can either fill 1 or 7 or 9 here. We can't put 8 here again because we have put 8 here already. So now think about it. Suppose tens place we have put some digit. Suppose we have put 9 here. Well, we can't use 9 here again. We can't use 8 here again. Now in this place we can choose from either of these 2 digits. In 2 different ways we can place the 100 place, right? So in how many different ways can we fill these 3 places with 3 digits where repetition is not allowed is equal to 2 into 3 into 4 is how what?
So
So
24.
24 different ways.
That means 24 such 3 digit numbers will be obtained. Okay, 24 such 3 digit numbers will be obtained. Okay, see, this is the last one. I'm just going to put a once more modification here. Bit 3. 7 must occupy unit place. 7 must occupy unit place, and a repetition is not allowed. So you see, I made the question a bit more interesting. Okay, what are the digits available for us? 1, 7, 8, 9, right? These are the digits available for us. Same 3 digit number we have to form: ones place, tens place, hundred place. Well, here there are 2 conditions here it has given us. First condition, you can't repeat any digit, and the second condition is 7 must occupy the unit place. That means in the unit place or the ones place,
Once.
you don't have any choice. You have to put 7 there, or compulsorily. Question is that 7 must occupy the unit place. You get it?
Yes, sir.
Yes, sir.
So you see here.
So there is only one way.
Yes, but keep in mind here one thing, guys. Here there is a restriction in the ones place, isn't it? Because ones place cannot be ones place can be filled by only 7. You can't fill 1, 8, 9 here. There is a restriction here, right? So remember, whenever there is a restriction, wherever there is a restriction, you must start with that place. Okay? Unlike in the previous cases, in these cases, you could have started from the hundreds place also. You would have got the same result. But in these cases, you have to start from the place where there is restriction. And where is restriction here? Here the restriction is at unit place. You have to put 7 here, compulsory. That means this place can be filled in how many ways? 1 way.
Wait.
One ways.
So that means 7 is useless now. 7 is useless to us. We can't use 7 at all because 7 is, this place is has taken 7 and repetition is not allowed. So we can't use 7 again anywhere. So now when we want to fill the tens place, we can fill.
We have
by
3 different
1,
ways.
8 or 9.
So 3 ways.
Now suppose out of 1, 8, 9, any one you have put here. Suppose 9 you put here. Now when you go to
2
put,
different ways.
2
So
different
2
ways,
different ways.
right? So in how many different ways
So
can you
total
do
6
this?
different 3-digit
Six
numbers can be
different
made.
ways.
So 6 such 3-digit number can be made where 7 must occupy the unit place. अच्छा, अगर बोलता, I mean, if it had said repetition is allowed, if the question was repetition is allowed, and 7 occupies the unit place.
So 16. Different 3-digit number can be formed.
Now think about it. Of course, only one way here, right?
So 4 ways at the 10th place, and the 100th place it is also 4 ways.
You get it? Hello, get it?
Yes, sir.
Yes, sir.
So thank you guys. Thank you very much. Take the screenshot. And this was for today. Tomorrow at 4:30 there will be class. If there is some change in plan, I will tell you. I'll inform you in the group. But for the timing, let's have the plan to have the class at 4:30 in the afternoon tomorrow. Okay. Take the screenshot. Done.
Done, sir.
Yes, sir. Done.
Done, sir.
Take it. Done.
Done,
Oh.
sir.
Oh.